Unit 6, Day 50 Notes for Calculus, Part 2. This is dealing with the fundamental theorem of calculus, Part 1 of the fundamental theorem. And we have a couple examples here. We have 3 examples here, still using the same line from uh, Part 1 of the notes, but now the intervals have changed. So we're now going to have part of the area is going to be above the x-axis and part's going to be below. So we're going to do this out taking the integral first, finding the antiderivative, and then taking the definite integral by going over the given um, interval points, and then we'll check it by doing it the old-fashioned way. So let me do each one, and then you can try to do it, and then we'll go back and check. So the integral from -1 to 4, we knew that the antiderivative is negative x squared plus 3x. That's the same thing we've been doing, but now our lower limit and upper limit has changed. So it's the definite integral is we substitute in the upper limit first, and then subtract the value when we put in the lower limit, and we end up getting 0. And if I treated these like two triangles, area equals 1/2 base times height, with that base 2.5, obviously this goes up 5, so there's our positive 5, we get 6.25, 2.5 here, but now we're going down 5, so we get negative 6.25, which is 0. Let's do the next one. And again, I'll let you guys check it out. We just changed the interval. Obviously, we only went over to 3, so that made this triangle smaller. So everything was the same here. We got 6.25 for the area of that triangle minus 2.25, so we get a total area of 4. If we use the integral, we get same value. Okay, let's do the last one, and that'll be it for part 2 of the video. Okay, now we change the interval. We slide a little bit further to the right, and we go from 0 to 5. We can see the triangle above the x-axis is going to be much smaller, and therefore below the x-axis is much bigger, so we're going to end up getting a net area of -10. And whether you do it the old way or using integral, we get the same answer. Okay, area equals -10. And actually, before we finish up part 2, let's look at the results of those 5 examples. What inferences can you make about the value of the definite integral and the amount of area bound by the graph of the integrand and the x-axis? So the integral from a to b of fx dx area is equal to the area of the region bounded by the function f of x and the x-axis. Second thing we can come up with, the integral from a to b of f of x d of x is positive or greater than 0 if the region bounded by the function and the x-axis is larger than the region below on the closed interval. So again, if it's region between the f of x above is greater than what's below, then the integrand is going to be positive. Integral from a to b of f of x dx is less than 0 if the region bounded by f of x and the x-axis below the x-axis is larger than the region above on the closed interval from a to b. And lastly, the integral from a to b of f of x dx is equal to 0 if the regions above and below are congruent on the closed interval. Okay, so those are, oh, I skipped one. Did we skip? Oh, it was from the previous 5 examples. So those are the 4 things we could conclude. Okay, I should probably add this. I think I left that out. So it's greater than 0 if the region bounded by the function and the x-axis above the x-axis is larger than the region below. Okay, and this is the x-axis below the x-axis is larger than the region above. Okay, that's it for part 2.